Finally, our final part, energy changes in simple harmonic motion. So simple harmonic motion, like any other motion, kuna two types of energy. Kuna kinetic energy na potential energy. Na kwa namna pekee, potential energy can be stored in two ways. Okay, potential energy is stored in two ways. If a spring is hung namna hii, potential energy is first stored due to distance above the ground, na potential energy is stored in the spring. So kuna two types of potential energy, na kinetic energy due to its movement. But ikiwa imelala horizontal namna hii, suppose iko kwenye spring and we have a body, so we don't have the potential energy due to the height, we only have due to the spring. So we shall see this. Now how do they vary? We remember tulisema kwamba kwenye motion, okay, velocity is maximum at the mean. Here is where the velocity is maximum. It means since the kinetic energy depends on the velocity, the kinetic energy is also maximum when x is equal to 0 at zero displacement kwenye mean. Kama ilivyo kwenye maximum velocity is inapatikana kwenye mean when x is equal to 0 no displacement, vile vile kinetic energy maximum inapatikana kwenye mean when x is equal to 0. And so let us imagine you have a stretched or compressed spring. So potential energy is a work done by the spring. So the average force times the distance. Okay, that's what is causing the work done to be done in the spring. So the average force inakuwa F divided by 2 because we have two forces. Force ambayo inaipeleka mbele na force ambayo inairudisha to the mean. So we have a certain average force. Kwa mfano if your body is moving kuja chini, there is a restoring force causing it going back there. So average force of this plus this ambayo ni manake F plus F divided by 2. It's the average times distance. So we have Fx divided by 2. And by Hooke's law, force ni sana K times X. So if we substitute F hapo tukaeka Kx, manake inakuwa ni Kxx divided by 2. Kwa ndo maana potential energy in the spring is given by a half times spring constant times x squared, where x is spring constant, x is displacement. When oscillating, the spring mass system possesses kinetic energy. Okay, when oscillating, the spring mass system possess the kinetic energy. And so kwa kukazia point ya y f over 2, remember kwa mfano hapa kuna mg. Okay, now huko kuna restoring force F. So there must be an average of the two. Under equilibrium condition, F na hii ni F zinakuwa zinafanana. So hii ni F na hii ni F under equilibrium conditions. So the average is F na F plus 2. Zinakuwa 2F. I mean zinakuwa ni F hizo divided by 2. Kwa inakuwa ni total F divided by 2 because it is split into 2 between force inayoenda juu divide kwenye force inayoenda chini. Kwa F ya restoring plus mg divided by 2. Kwa inakuwa ni restoring total net force divided by 2 because kuna inaenda juu na inaenda chini. That way. So where total energy in the mass spring constant, mass spring system, potential energy plus kinetic energy. So as usual, kinetic energy is half mv squared. So we have potential energy half kx squared plus kinetic energy half mv squared. Imeisha. But we remember kwamba displacement ni a sin wt na velocity ukidifferentiate hapo ni aw cos wt. So if we substitute, okay, kwenye kx, kwenye x tukaweka a sin wt, maana yake a sin hii ndio x square, because a sin wt ni x, so x square inakuwa ni a square sin square wt. So similarly kwa velocity, kwa a half m hii ndio v square, ukisquare hivi unapata a square w square cos square wt. Lakini vile vile tunakumbuka kwamba w square ni sawa na k over m kabisa, tulivyokuwa tuna derive equations kule za spring mwanzo kabisa. Yeah. Okay, w square ni sawa na k over m. That means instead of k we can put w squared m. Okay, because k is sawa na w squared times m. So instead of k we can put w squared m, so in k. So if we want to simplify it, sin square theta, sin square wt plus cos square wt, we can small and common. So we have a half a square w, a half m a square w, na half m a square w, so ndani inabaki sin square wt na kwa hii mathematically ni 1. Kwa tunapata total energy ni sawa na half mw square a2, or which is a constant according to the conservation of energy, law of conservation of energy. The total energy is always a constant. So if you observe this clearly, utaona kwamba mw squared, this is k, so hii ni sawa na a half k a squared, ambao basically it tells us kwamba ukichukua half k, and it means kwamba kwenye maximum displacement we only have the potential energy. Okay, kwenye maximum displacement we only have the potential energy, and it is logical. Tulishasema velocity is maximum kwenye center, x is equal to 0. Huko kwenye extremities, kwenye amplitude ni sawa na 0, velocity inakuwa sawa na 0. So the energy is purely potential energy kwenye amplitude. So the total energy is always equal to the potential energy. Lakini potential energy wapi? Ikiwa to the kwenye amplitude. You can see hapa kwamba this is the energy versus time. Kwa kwenye mean, kinetic energy is maximum. Ukiambiwa uchore diagram ya energy versus time, kinetic energy is maximum kwenye mean, potential energy is minimum kwenye mean. You can see inaenda namna hiyo. Zinaenda zinapishana namna hiyo. Okay. Yeah. So this is what they are trying to say here. So energy versus time, ukiambiwa uchore, this is the diagram they want you to